Hey everyone, this is Module 5, Lesson 3. We're using chance experiments with equally likely outcomes. However, I think that the essential question, what is a sample space, is more appropriate. So we're going to talk about what a sample space is, and we're going to be using those data or experimental probabilities to help us. Okay, let's go ahead and read example 1 together. Jamal, a 7th grader, wants to design a game that involves tossing paper cups. So if you can imagine like a paper cup or a plastic cup, one of those disposable ones, it says that he tosses it 5 times and records the outcome of each toss. An outcome is the result of a single trial of an experiment. Please underline or highlight that. An outcome is the result. So it sounds like what it is, an outcome. Okay, what was the outcome? Like if someone says, what was the outcome of the test or the quiz or, whatever an experience is, what is the outcome is what happened. So what is the result? All right, here's the results of each toss. So it says that he did it 5 times. The first time it landed on its side. The first time it landed upright. The second time. The third time it landed upside down. The fourth time is on its side. And the fifth time on its side. So he sees, based on those 5, that it could land one of 3 ways. It could land on its side, it could land right side up, or it could land upside down. The collection of these 3 outcomes is called the sample space. Okay, sample space is the set of all possible outcomes of that experiment. Okay, so we have 2 vocab words here: outcome, sample space. For example, the sample space when flipping a coin is heads, tails. That's it. You have 2 options. And so when you list those 2 possible outcomes, that's called the sample space. Okay, so if you are drawing a colored cube from a bag that has 3 red, 2 blue, 1 yellow, and 4 green, the sample space is all the possible outcomes. So what could possibly happen? You could pick out a red, you could pick out a blue, you could pick out a yellow, or you could pick out a green. It doesn't really matter how many of each there are when it comes to sample spaces. You're just listing all the possible outcomes. So again, it's all the possible outcomes. Okay, for exercises 1 through 6. For exercise 1, for each of the following, list the sample space. Okay, and again, just in case you forgot, it says it right here. That's all the possible outcomes. So if we're going to draw a colored cube from a bag, imagine that there are 2 green, 1 red, 10 blue, and 3 black. What are all the possible outcomes? Okay, so we could pull out what color? We could pull out green. We could pull out red. We could pull out blue, not blur, or we could pull out black. Okay, that's it. That's all there is to sample spaces. It doesn't say like which one is the greatest chance of happening, which one's the least chance of happening. It's just saying what are the possible outcomes. So you could pull out green, red, blue, black. Okay, if you toss an empty soup can and see how it lands, we could say very similar to the cup up there. It could land on its side. And then it could land right side up or upside down, just like the cups from above. And keep that in mind because there's a part where you're going to actually perform your own experiment. Okay, how about number 3? Shooting a free throw in a basketball game. I'll give you a hint. There's 2 outcomes. What could happen if you shoot a free throw? You could make it, or you could miss it. Now, I know that some of you are thinking like, well, it could hit the rim and bounce out, or it could hit the backboard, or it could be an air ball. Well, that is true. There are different ways that you could make it. There are different ways that you could miss it. But what's important in the basketball game is it either goes in or it doesn't. So you either make it or you miss it. Okay, how about number cube? So they're talking about dice here, or a singular die, but really the word dice is what's more popular and makes sense. So I'm going to say dice a lot. Rolling a number cube with the numbers 1 through 6. So this one, you probably can imagine if you're playing a game and you have to roll the cube, what could happen? In fact, sometimes like when I have 2 dice and I'm playing Monopoly, I think like, okay, I really want to land on this spot, so I need a 5, or I need a 3, or I need a 7. But you can't get a 1 if you're rolling 2 dice, or you can't get a 13. Or sorry, you can't get you can't get a 13 because the highest is 6 and 6. Now this one is just saying one number cube. Okay, it's not talking about 2. So if you just have one dice, you know, it's got 6 sides and it's numbered 1 through 6. Right? So what are the possible outcomes? You could land on a 1, a 2, a 3, a 4, a 5, or a 6. And that's it. It's going to be one of those. It's not going to be 0. It's not going to be 7. Okay, number 5, selecting a letter from the word probability. Now this one is kind of interesting because what it's saying is, if you could imagine like taking the letters of probability like P, R, O, and putting them all in like a bag and then drawing them out. So it's saying what are all the possible letters that you could draw out. Okay, so you could draw out a P, you could take out an R, you could take out an O, you could take out a B, you could take out an A, but guess what does not come next? It's not the letter B again. We already listed B as a possible choice, so we don't list it again. Okay, the next letter after the B is the I, and we haven't listed that yet. And then L, we haven't listed that as a possibility yet. But then there's another I, so I don't need to list that I. I already have I as a possible solution. So it's like saying there's 2 I's, but I is a possibility. I don't list it twice. T is a possibility, and Y. Okay, so you don't need to list the second B or the second I when you do that. Okay, try number 6 by yourself. What are the possible outcomes if you're to spin this spinner? What could it possibly land on? Okay, it's no trick question here. Sometimes some spinners do have trick questions. It's just all the numbers 1 through 8. 1, 2, 3, 4, 5, 6, 7, 8. It doesn't go around in order, but they are all still there in each one time. Okay, I want you to write for number 20. Now I'm going to have you write this must be completed in class. The reason I'm having you do that is because a lot of kids, if I write in class, a lot of kids don't think that it counts. And so then they'll say like, well, you didn't do it in the video. I just want you to write this so that when you are trying to figure out what you're supposed to do, that this is included. Okay, so you're going to complete this in class, and you're going to be doing this paper cup toss. You can do it with a partner. All right, so you'll be flipping and recording the outcome, just like Jamal in that original example when we were imagining it. Okay, so you'll have a disposable cup, and you'll be doing that in class. Okay, and then again, the exercises go with that. So you can write that at the top of page 21 as well. Okay, once you've written that, you can turn the page to 22. Using the spinner, answer the following questions. Okay, I want you to go ahead and answer part A by yourself. Okay, go ahead, pause it and answer part A. And then actually do B too. Do part A and B, and then unpause it and see if you have the same thing I do. Are the events spinning and landing on a 1 or a 2 equally likely? So what it's saying is landing on a 1 equally as likely as landing on a 2? And the answer is yes, because the sections are the same size. There is a 1/4 chance of landing on either a 1 or a 2. Okay? So it's equally likely to land on a 1 or a 2. But what about landing on a 2 or a 3? That one is no, and a lot of it has to do with the fact that the sections are not the same size. No, because the sections are not the same size, and we can say there is a 50% chance of landing on 3 and a 25, I'll make this smaller, and a 25% chance of landing on 2. Okay? So you can also call that 1/4 and 1/2. So landing on a 3 is 1/2, and landing on the 2 is 1/4. Which you should know all these very well from our last module. Okay, how many times do you predict the spinner will land on each section after 100 spins? Okay, so it needs to equal 100, and this is just predicting. This is not what's really going to happen. You're just saying, what do you think the chance is? Okay, so let's make 3 land on 1, and then we'll say land on 2. Pause it and try to do this on your own, okay? Predict how many times it will land on each if we have 100. The first one I would do is the land on 3, since that's half. Okay, so how many times would it land on 3? It would be half of the times, which is 50. And you can even put half in parentheses if that helps. Okay, then the other 50 times would be split between the 1 and the 2. So I would say that each one of those would be 25. 25 times, which is 1/4. And then same thing with landing on a 2, 25 times. And how can we check that that makes sense? It should add up to 100. Okay, now that doesn't mean it's going to happen. All right, that's just a prediction based on theoretical probability and the size of the spinner sections. Okay, again, 25 is 1/4 of 100, 25 is 1/4 of 100, and 50 is half of 100. Okay, go ahead and draw a spinner that has 3 sections that are equally likely to occur when the spinner is spun. How many times do you think the spinner will land on each section? Okay, I'm going to use A, B, C. And I like to split it into thirds like that. So here's A, here's B, and here's C. Okay, now it's not going to be exact, but I'm going to say about how many times for each section, if it wants to be 100. It's going to be about 33. Now, if you want to get technical, it's 33 1/3 or 33.3 repeating. Or you could even say, okay, I think it'll be 33 times on these two and 34 times on that. I'm just going to say about. So pay attention to that word about because it's not exact. Okay. All right, go ahead and complete the summary, and then that's going to be a wrap because I had told you already that on pages 20 and 21, you're going to be responsible for that in class as along with the independent practice.